Assalamualaikum warahmatullahi wabarakatuh. Good morning, Mr. Kevin Harada and Mr. Listio Edi Prabowo ST and other happy friends. First of all, let us say thanks, grateful, and pray to Allah Subhanahu wa Ta'ala for giving us the grace of health so that we can be here together for the presentation. We are from class 166, group of 4. Today we will discuss about the virtual memory of Linux. Let us introduce ourselves. My name is Hakimatul Basyair.
My name is Gafrilatif Afiandi Putratnanta.
So my name is Damar Wicaksono. Table is of contents. One, definition of operating system Linux and memory virtual. The second is virtual memory in Linux. The third is how to the virtual memory work on Linux. Four, how to create or increase virtual memory size on Linux. And the sixth slide is VM virtual memory start, and the last is tracing. So in this slide, I will tell you about definition of operating system Linux and virtual memory. Linux is a computer operating system software. Linux is a development of Unix and can be used on a variety of computer ranging from Intel x86 to RASC. And the advantage that exists in Linux program is especially for programmer and network administrator are the freedom to obtain the source code and the freedom to change or modify it. And the virtual memory is memory management used by the operating system to use a portion of the hard disk. And virtual memory on Linux is support in Linux, that is using a disk as an extension of RAM so that the effective size of usable memory grows correspondingly.
Next is how to create or increase virtual memory size in Linux. Of course, there are several steps to increase or create virtual memory size, but when you're using Linux, you don't actually need to create a virtual memory. Because when a Linux system is initially set up, a swap partition will be created on the hard drive that will be the virtual memory in Linux. But if you think that you don't have enough virtual memory, you can increase it by creating a swap file. And here is how to create a swap file. The first step is to open up your terminal and determine the amount of free space available with the df command. Decide upon the size of the swap file based upon the amount of free space. And step 2 is to create a swap file of the size decided upon earlier with the command sudo space dd space if equals /dev /0 of equals /mnt /swap file space bs equals 1 capitalized M space count equals 1024, where 1024 is the size of the swap file in megabytes, and the full name of the swap file is /mnt /swap file. Step 3 is to format the swap file with the command sudo space mkswap /mnt /swap file, and then you need to enable the swap file with the command sudo space swap on /mnt /swap file. The new swap file will not be used after a reboot unless the system is told to use the swap file. You can edit the /etc/fstep file and add the following line in /etc/fstep to make the swap file persistent between reboots. /mnt /swap file space none space swap space sw space 00. Next is VM stat. As its name suggests, it reports virtual memory statistics. I highly recommend you to use a VM stat if you want to see your virtual memory statistics. And I highly suggest you to put it on a 5-second delay. In order to do that is to just open up your terminal and type vmstat space 5. That will put it on a 5-second delay. This vmstat can also help you prevent thrashing from happening. As I said before, vmstat can help you prevent thrashing from happening because with vmstat you can see the statistics of your virtual memory and see if a thrashing is going to happen. But what is thrashing? Well, as you can see from this graphic, the CPU utilization keeps on going up and up until it reaches its peak and balances with the degree of multiprogramming. But as it goes on, the CPU utilization keeps on going down while the degree of multiprogramming keeps on getting higher and higher. That is called thrashing. But if you really want to know what thrashing is, we need to understand about page faults and swapping. We know how every program is divided into some pages, and when a program needs a page which is not in the RAM, that is called a page fault. And whenever a page fault happens, the operating system will try to fetch that page from the virtual memory and try to swap it with one of the page in RAM. That is called a swapping. So what is thrashing? Well, if this page fault and swapping keeps on happening very frequently at a higher rate, then the operating system has to spend more time to swap these pages. This state is called thrashing. Because of this, CPU utilization is going to be reduced. But of course, there are ways to prevent and recover from thrashing. The way to prevent thrashing is not only by using vmstat, but it is to also by instructing the long-term scheduler not to bring the processes into memory after the threshold. Basically, it limits how many processes can happen in one time. And what if the thrashing is already happening? How do I recover it? Well, if the system is already thrashing, then instruct the midterm scheduler to suspend some of the processes so that we can recover the system from thrashing. And that is what thrashing is, how to prevent it, and how to recover it.
Next is conclusion and suggestions. So our conclusion is Linux is a computer operating system software that is free for distribution under the GNU license. Although Linux is free, the GNU license allows those who wish to charge a fee for copying and using the program. And virtual memory is a memory management used by the operating system to use a portion of the hard disk. Linux supports virtual memory that is using a disk as an extension of RAM so that the effective size of usable memory grows correspondingly. The kernel will write the contents of a currently unused block of memory to the hard disk so that the memory can be used for another purpose. Physical memory, the actual RAM installed, is a finite resource on any system. The Linux memory handler manages the allocation of that limited resource by freeing portions of physical memory when possible. All processes use memory, and the kernel frees up physical memory by writing some or all of process memory to disk until it's needed again. The kernel uses paging and swapping to perform this memory management. Paging refers to writing portions, turn pages, of a processed memory to disk. So, in our suggestion, Linux supports the use of virtual memories, and it will always be there as soon as you set it up. You can check it out by typing free in your command terminal. You should also know that you can increase its size by creating a swap file. This means that if you only occasionally need an unusual amount of swap space, you can set up an extra swap file at such time instead of keeping the whole amount allocated all the time. Also, you should set up a vmstat so you can see the statistics of your virtual memory and its activities. And finally, you need to be careful about thrashing. So start by instructing the long-term scheduler not to bring the processes into memory after the threshold. That should help with preventing crashing. Thank you. That's all from us. Wassalamualaikum warahmatullahi wabarakatuh.